Okay, so doing a practice problem for like number 2, and so I'm going to go ahead and do something that looks a little different. And in this case, I know I'm going to end up being with a decimal, so I'm just going to make one up as I go. I'm going to try and get it kind of to make sense. So on number 2, it says that athletes, you're talking about a projectile being shot, and this one is a shot put, and you want it, the release angle actually doesn't apply in this, but is going to be modeled by the function. And so I'm going to go ahead and give you guys a function. So let's say that my function that it was modeled on, I know I need to have a negative. I'm going to go ahead and do the meters squared. So I know that it should be something like negative 9.8 x squared. Oh, I should, yeah, x squared. I want to go ahead and plus point. Let's go 0.8x, and then I'm going to go release plus 2. All right, and the reason I do this, I know ahead of time that this is eventually, when you guys start working on your calculus, you're going to find out that's going to be your gravitation, your acceleration. And so when I drop an object, or if I throw an object, the force that's based on that's pulling against it is gravity. And so the negative 9.8 is basically your gravity in meters per second squared. Okay, and that's kind of where I know that. And then I also know that I'm going to have a release height of about 2 meters. So 2 meters is pretty tall. That would be about 6 feet. But say that we're on a ledge or something. So my graph of my function here would look kind of like this, okay, somehow. And I don't know if I've got it exactly right, but what I'm going to want is to find out the maximum height, and then also how much time has passed when the time at the maximum height. Okay, and so in this case, if I know that I have an inverted parabola, then I'm looking right here to see that this is going to be my maximum height. It's also considered what of your parabola? The vertex. Yep. And so on this case, I'm going to say, well, I know that if I can find my x, how far I'm going to go over on my time, if that would be, then the formula for x is going to be a minus b over 2a. And that's the formula we talked about at first when we did our parabolas. Okay, so the x value is going to be the minus b over 2a. So in other words, I'm going to take my b value, so I'm going to go a minus 0.8 divided by 2 times a negative 9.8. And that will give me the x value and the time that maximum height occurred. So in this case, on my example that I'm giving you, I would have then clear 0.88 divided by, and I'm going to 2 times 9.8. And sometimes you guys might notice that, oh, that's only 0.4 seconds. So it's 0.04. I'm not sure my problems is true to life, but then I'm going to go ahead and find f of 0.04, and I'm going to put it back into my equation as negative 9.8 times 0.04 squared plus 0.8 times 0.04 plus 2. In fact, you know what, guys, before I do this, if I were just to take 8, this might be more true to life. I think I switched my feet per second squared. If I go 8 divided by 2 times 9.8, that might be a little more realistic. Let's just change this one. Can you guys erase the 0.8 here, making it just 8? It's still a little bit small, but then it's not so much, it's not quite as small. So then that changes it to then 0.4 seconds. And then this will also be then 0.4 squared. And then I'll also have 0.4 here. So on the next one, I'll go then, I'm going to square this and take it times the negative 9.8. and I'm going to get then the negative 1.63 plus I'll have 0.8 times 0.4. That's going to be 0.32 and then plus 2. So plus 2 minus, and I'm going to come up and then grab that. And so at then 3.95 meters would also be then my height. So this point right here would be then 0.4 comma 3.95. Okay, so that means my height is going to occur after 0.4 seconds, and it's going to be 3.95 meters. Now the second part of the question is that when is it going to hit the ground? So the next part of it is going to be when is it going to actually hit here?
So basically where your x-intercept is?
My x-intercept. And to find your x-intercept, you would want to go ahead and use your...
the negative b.
Yep, the quadratic.
Yeah.
Good, because I'm not going to be able to factor this, obviously. So I'm going to go ahead and put it in then to a minus 9.8 times, I'm going to go ahead and minus b. Goodness, I'm having a problem. So minus 8 plus or minus the square root of b squared, which is going to be 8 squared minus 4 times a, which is a negative 9.8, and then times c, which is 2, all over 2 times negative 9.8. So when you do this, inside I know I'm going to get a positive number because this is going to change this to plus. So I end up with then, I'm going to have 8 squared. Of course, you guys do differently on your calculator. Let me go clear. I'm going to go 4 times 9.8 times 2, and I'm going to get 78.6 plus then 64. And so I have the square root of 142, and so that's going to end up being 11.9. So I actually have then a negative 8 plus or minus about 11.993 all over 2 times a negative 9.8. So the two parts that you're going to have, you're actually finding these two intersection points. But the first one, if you notice, if I take the negative 8, a minus 8, and I subtract my 11, and then I'm going to get a negative number, so I'll have a negative 19.9 divided by 2 times 9.8, which would be a negative 19.6. So when I divide those two numbers, they'll get a positive number. So negative 9 divided by that is going to give me then a positive 1.01. But my next one, if I go a negative 8, but then this time I'm going to add then 11.98, so I'm going to go grab it. I get 3.9, but now I'm dividing it still by my negative 19.6. I'm going to get a negative number. So that's where the negative 0.2, that's going to represent the point that's actually behind my x-axis, all right, which really doesn't matter. I mean, because what's happening is I'm starting here at 2 meters. I'm going to make my projectile go up here, and then it's going to fall. So it's actually going to fall where the first value is going to be positive. In this case, it's going to be 1.01. But it actually will also go behind also, which we won't worry about because that's like going back. It would be 0 time or negative time. But then they also ask, well, what is the value of x when you start? When x is equal to 0, what was your value? 2. And that's the height in which you'll start with. So f of 0 was going to equal then 2. And so that's the height in which you will start. From the height in which it's released. Yes? You sure can. Okay, does that kind of make sense on how to do that one? Somewhat. Okay, try this one. I think number 2, you actually get a little bit better since I made it up in my head. Sometimes I always have to worry about making stuff up in my head. It doesn't come out as nicely. So, but this one is still going to be a decimal, but you guys, it'll also be a good application because it'll be something that you guys will have if you continue on in mathematics.